Hello, and welcome back to our Summit BIM podcast, Data Matters, continuing our series about BIM, Building Information Modelling or Building Information Management. In this episode, I'm going to focus on lessons learned from the perspective of the owner, relative to projects where we have been directly involved, but also lessons others in the industry have learned and shared. The focus will be on common issues and designed to give you some idea of the potential consequences associated to these following risks. So 1, not managing the BIM, or in reality not managing the data process. Being vague in your BIM requirements. Teams failing to undertake what they have signed on for, i.e. non-compliance. Failure to define strategies and collaborate. A lack of understanding of the data value and its downstream uses, and misunderstanding the BIM process. So first, let's look at the risk of failing to manage the BIM process by not addressing the change management aspect. On any project, there should be a QA/QC process in place, followed both internally within the teams and externally by the client at agreed milestones. On larger projects, these checks are often undertaken by a compliance team. However, most of these quality processes are undertaken by viewing the 2D drawing output and not the underlying data. It is surprisingly easy to use a software tool like Revit to create 2D drawings, with the underlying dataset being virtually unusable for any other purpose. When following a BIM process, where the goal is to be able to rely on the underlying dataset for maintenance and operations, the data must also be part of that QC process and checked to ensure that there is consistency and structure and that all the required data parameters have been filled and standards followed. This need for data QA/QC checks is a change in the current process, adding a new specialist consultant team to the client oversight compliance team, and clearly has a cost. Related to the need for this compliance check is one of the biggest challenges. How do you manage the process when a team fails to comply with the requirements once they have won the project, or fails to update issues flagged during a compliance audit? What clauses do you have within the contract to ensure compliance? Is it the carrot or the stick? Typically, the end goal of getting the building built is paramount, and the excuse of "it will take longer" often overrides the requirements, with the 2D drawing output taking precedence. Some design teams may charge clients additional fees if they are required to adhere to a set of BIM requirements. Second, the risk of vague BIM requirements. There is considerable risk involved when an RFP is issued with loose or vague BIM requirements, or even worse, simply asking for BIM. The problem is that without clarity, it's very easy for all parties to make their own assumptions as to what the requirements mean. Typically, this will be the minimum required to ensure a competitive fee. As mentioned in the previous podcast, BIM costs money. One must also remember that consultants and contractors are businesses who are working to maximise their bottom line. Vague BIM requirements often mean that the consultant or contractor workflows will trump yours. In this scenario, their preferred workflows and processes take precedence, and owners may or may not succeed in achieving their goals and uses for the data. This is a common situation, one that will hopefully improve as the industry matures and gains a better general understanding as to what BIM is. As mentioned in our first podcast, many organisations think that if they are using technology, like Revit, to generate 2D drawing output, then they are doing BIM. They most emphatically are not. BIM is a data-driven process, not a piece of software or technology. The challenge with vague BIM requirements is that it's very difficult to hold any team accountable for outcomes related to data quality and to following required processes as well as standards if they are not specifically identified. The AEC/OO industry is not known for following consistent standards, such as common naming conventions or the use of a classification system to identify objects. The industry and the contracts are still focused on the 2D drawing output, with each organisation using their own naming systems. We have seen several common responses from teams during different projects, even with BIM requirements in place. They tend to be along the following lines. We don't model those elements. We only model typical flaws. We don't include scheduled information in the model dataset. We didn't think we had to do that, or we didn't understand that to mean we would need to do that. That's not our job. The contractor will coordinate that on site. We don't do record model updates during construction. We wait until the end when the project is complete. The challenges of non-compliance, even with a robust set of BIM requirements, teams will search for loopholes to try to wiggle through. How, as an owner, do you audit the data and manage this issue? Currently, most owners don't have internal teams with the required expertise to undertake BIM compliance audits, a vital series of steps in the BIM process. If the data is to be used, it must be trustworthy. What do you do when the issues are flagged and the teams fail to rectify them? It's very important, if this happens, that the owner is firm and consistent, appreciating the downstream consequences of such non-compliance regarding the final deliverable. The excuse, most often given by design and construction teams, is that the traditional paper process is more efficient for them. In that process, the 2D drawing output was the contract. However, as we move into a digital workflow, the model dataset that generates those outputs is also vital and needs to be part of any QA/QC process that is being followed. All drawing views, with a few exceptions, i.e. schematics and single-line diagrams, should come directly from the database. Also, there's a risk associated to failure to define strategies and to collaborate. BIM is a team activity in which all participants need to agree to follow the same process, strategies and workflows. It is about sharing information and reusing what other team members have generated. Design inherently requires multiple different disciplines to work together. In the paper process, everyone generated their own drawing output. In a BIM process, they need to use the model data generated by others. This requires trust and cooperation. If each team generates their own model data without considering whether it already exists in another team's dataset, then there is obviously a huge risk of duplication. If duplication occurs, how are teams going to manage and identify which set of data is to be used? There are many ways of managing this, but it must be managed, especially if the dataset is going to be used to support estimating during design. Another risk is of teams failing to model repetitive standard flaws. In a paper-based process, a single floor plan would be used to represent multiple floors. In a BIM process, all floors need to be modelled to enable assets required for maintenance and operations to report the correct level and room. There's also often a lack of understanding of the data value and the downstream uses. The value of a BIM process is in being able to use and reuse the data for the goals and uses defined in the BIM requirements. A robust set of BIM requirements sets out what the intended uses are for the data. It's important to understand where use of the data set can provide additional benefits to help you, as the owner, manage a project more effectively and efficiently. For example, on a hospital project we were involved with, the IMIT team wanted to be able to understand what walls and doors had changed location and/or type between submissions. By running a comparison between the two submission datasets, we were able to identify and highlight, using colour, those walls that had moved and changed type, or just changed type. This provided valuable information to the IMIT team, far faster and more easily than it would have taken them to undertake this task from the 2D drawing submission. This was not a predefined use. However, the client asked whether the data could be used for this purpose, and the answer was yes, absolutely. In a similar way, aside from virtual coordination to ensure the pieces fit and there is the required space for maintenance and operations, the underlying data can be used to drive multiple other processes, for example, to support estimating, environmental and energy efficiency checks. The ability to use this underlying data relies on the quality of the dataset. Is the required information present in the correct format, in a consistent location, etc.? Data is inherently rigid. If you have a space or a dash separating two words or numbers, the computer will consider them as different types and searches and queries will not return consistent information. Consistency is key and must be agreed and established at the outset and then strictly followed. However, a very common non-compliance issue we see, one that has significant downstream consequences, occurs when the design consultants generate schedules in Excel and then create an image to use on the sheet view. With this workflow, none of the required information is present in the software database. This means that the most of the assets that are of interest to FMO, i.e. mechanical equipment, have empty data parameters that the FMO team require for the life cycle. Thus, rather than being able to reuse the data, someone needs to manually input the information at some point in time prior to handover. There's often a general misunderstanding of the actual BIM process. The history of the AECOO industry is firmly based on the generation of a set of 2D drawings with a specification. One of the risks that we see is a belief by the owner groups that the design team output, their models and dataset, will automatically provide them with what they need. Our experience shows very clearly that the quality of the dataset needed to generate a 2D drawing output is very different from the quality required to drive downstream uses. If not specifically asked for and defined, the owner group discovers after years of work at the end of the project that what they have been handed is of no value to them. The duration of the project design and construction cycle is years long, and the lack of a controlled process comes home to roost when it is far too late to make any changes and salvage the data. This then leads to owners thinking there is no value in the BIM process. This issue only emphasises how important it is to start off on the right foot, with clear requirements. Requiring BIM is a different skill set from undertaking a CAD process. Remember, it's not the ability to operate different pieces of software, the tools. It is critical that owners ensure that they have the expert knowledge on their team, the information manager, as defined by ISO 19650, responsible for specifying and then managing the process to ensure that the outcomes meet the requirements. So what are some potential solutions to these issues? So what can you do to mitigate the issues or prevent them from occurring on your project? Several recommended solutions resolve several of the issues that I have mentioned. The following are some basic foundational steps that we would recommend starting with. As mentioned in episode 2, seek out and engage the required expertise to support you and your team in developing a robust set of BIM requirements, applying them and managing them on the project. Ensure that BIM is considered when reviewing the RFP responses. Firstly, does the RFP include questions related to BIM experience? Have they been addressed in the proposal? Frequently, the BIM component is not even considered against other aspects of the RFP response. Does the BIM requirement, if included, have a weighting in the assessment. It's relatively easy for a proponent to state how strong their BIM skills are, but have they been asked to demonstrate that they can actually do what they say? We strongly recommend that when reviewing RFP responses, which include a BIM component, there is someone on your team with the required BIM expertise to review this specific area of the scope. Follow the ISO 19650 framework. The most successful approach that we adhere to and highly recommend is to follow this ISO standard, requiring the proponents to provide a draft BIM execution plan as part of the RFP response. This ensures that the teams have already agreed to the process and defined their strategies. They are far more likely to stay on track rather than saying yes to win the project while in reality having no intention of following the process or having no understanding that BIM is not merely using Revit to create 2D drawings. What is a BIM execution plan? This is a document that identifies who is going to do what and when during the project, as well as how they will manage the process, i.e. the strategies and workflows that they plan to use. Although this approach requires more work from the teams during the RFP stage, it ensures that they have read the BIM requirements, understood what is being asked for, and thought out how they will achieve it. Consequently, they have also considered the work effort involved. Chances are, following this process, there will be far less pushback along the lines of, "We didn't think we had to do that," or "We have a different definition for coordination." In essence, it starts to close off any of those potential loopholes. Finally, manage the process. BIM is a data-driven process. Without quality data that can be used and reused in an iterative way to build a robust dataset that represents the entire facility at handover, it is not a BIM process. It is simply a paper-based process using new software. So, what are some of the conclusions that can be drawn? Well, there are a few takeaways from our lessons learned. Firstly, none of the issues flagged above are insoluble. They can all be managed. However, the management of the process and the QA/QC of the underlying data is a specialist skill set that is now required on capital projects as part of the owner team and needs to be included in the business case. The specialist skill set is based on expertise, not software knowledge. Secondly, the BIM process is fundamentally about the specification and management of digital information, i.e. data, all those zeros and ones. It is not using a different piece of software to create 2D drawings. As we all gain experience and move further into the future, the deliverable will not be the 2D drawing, but the model dataset, from which various parties can create whatever views they need. In addition, they can extract the precise relevant data subset from the project database to undertake a specific task, i.e. something like occupant movement analysis. Building Smart International is working to generate a common data schema that supports the ability to use and reuse, exchange and share across all software platforms. IFC 4.3, now certified as ISO 16739, while still retaining the fidelity of the original design information, a bit like a PDF. The data can be used and shared but not changed. In addition, specific data queries are being predefined, identified as Information Delivery Specification, IDS. This will enable the querying of datasets by extracting that predefined subset to an alternative software solution to run a specific check. In this podcast, the goal was to provide some examples of what can go wrong when the process is not clearly defined and managed, and if teams are not held accountable for what they have agreed to do. I hope you found it informative and enjoyed listening to it. If so, please subscribe to our YouTube channel, Summit BIM, or alternatively listen through Apple or Spotify. Also, please feel free to reach out to us at Summit BIM Consulting if you have any questions or would like additional information. Our next podcast is going to explore the BIM process from the perspective of the design and construction teams. All the best. Bye.